Hi everyone, my name is Chichen Li. Today my team and I will introduce the effect COVID-19 caused on the volatility of Australian dollars. And this is a list of our team members. And this is the structure of our presentation. And I will begin with the background information. So on March 11, the World Health Organization declared coronavirus disease 2019, as we called it the COVID-19, to be the global pandemic, which means the virus is being transmitted from human to human simultaneously in several countries around the world. So Australia had responded in time with a policy of travel ban from China to Australia in February and knocked out in March. With all these policies deal with COVID-19 spread, the global economy is in recession and the volatility of Australian dollar is affected as well. So our presentation will focus on the effect of COVID-19 on the volatility of Australian dollar and use models to analyze. So firstly, I will introduce the effect of COVID-19 and how it influences the exchange rate. COVID-19 has a huge impact on tourism because of the travel restriction. According to Australia tourism statistics, the tourism contributes 16.8 billion Australian dollars, which covers about 3.1% of GDP in 2019. And the international arrivals have plummeted since February 2020 after travel ban for China. And there were 677,000 visitors from China spent $12.4 billion in 2019, as is shown in picture. Compare between the international arrivals in 2019 and 2020. It is obvious that the arrivals slumted after COVID-19 because of the lockdown. It will affect the income in tourism industry and moreover the exchange rate of Australian dollars. Moreover, Australia has close trade ties with China, not only the tourism, but also some other business trading. The Australian construction industry will be impacted because of the raw materials arrives from China. Also, the car production is halted because of the lack of the raw materials as well. Because of the travel restriction, the number of the air transportation and the sea transportation has been limited. Therefore, the supply of the key raw materials cannot be afforded, which will affect the efficiency of both industries and furthermore the GDP of Australia. And according to the Australian dollar to US dollar currency chart, it shows that the market rate began to decline rapidly at the beginning of the March. And at March 23rd, the exchange rate hit bottom of 0.57. It is also the earlier stage of the ceiling, which began at March 20th. And then the exchange rate took about 6 months to get back to the lower level of 0.7. And now with the stable circumstance of COVID-19 infection in Australia, we can investigate the trend of the Australian dollar's currency and help boosting the Australian economy. So we will introduce some models to analysis and then focus the impact of COVID-19 on the volatility of Australian dollars. So let's move to our next part.
Hi everyone, I'm Jiaxin Ye. I will introduce a useful time series model for forecasting exchange rate, which is autoregressive integrated moving average model, also known as ARIMA model. The ARIMA model is a generalization of an autoregressive moving average model as learned from CAS. Both of these models are fitted to time series data, either to better understand data or to predict future points in the series. Due to the effect of COVID-19, the global economy is in recession. Investigating the trend of exchange rate is extremely important for financial markets. Firstly, ARIMA model are applied in many cases where data show evidence of non-stationary. An initial difference that is corresponding to the integrated part of the model can be applied one or more times to eliminate the non-stationary. The AR part of ARIMA model indicates that the involving variable of interest is regressed on its own lagged values. The MA part indicates that the regression error is actually a linear combination of error terms, whose values occurred contemporaneously and at various times in the past. The integrated indicates that the data values have been replaced with the difference between their values and the previous values, and this differencing process may have been performed more than once. The purpose of each of these features is to make the model fit the data as well as possible. For the formal definition of ARIMA model, we obtain the equation from a time series data xt, where t is an integer index and xt are real numbers. And a normal ARMA model is described as the equation. Assume that the polynomial 1 minus sigma of the product of parameters of the AR part and the lag operator has a unit root of multiplicity d. This form can be written as the new formula. In ARIMA process expresses this polynomial factorization property as given the new form. Thus, the ARIMA model can be thought as a particular case of an ARMA P plus DQ process having the autoregressive polynomial with d unit roots. The reason why we choose ARIMA model is we can use the past values of time series to predict future values. The dataset we obtained from Yahoo Finance shows the variation of exchange rates between AUD and USD in the past year. We are able to predict the future trend by applying the model based on this dataset. The effect of COVID-19 is unexpected for a global financial market. Thus, the prediction of the past year from the model should be different with actual exchange rates. There are three main steps for our model building. The first step, identification of test patterns. As mentioned above, we should eliminate the non-stationary before we apply a ARIMA model. The test of augmented Secure test is a good choice to distinguish stationary or not. After making the dataset in stationary, the second step, estimation of the model parameters and identifying the adequacy of the model. We should determine the PDQ for the ARIMA model. This can be done by plotting of ACF and PACF. Through the model, we can determine the AR term and MA term for the ARIMA model. Finally, we use the model to predict the future trend of AUD. For more detailed, we will show the process in our report. Forecasting exchange rate is always a very attractive topic in international finance. The ARIMA model will be an important part for us to investigate the effect of COVID-19 on the volatility of Australian dollars. The next part will be presented by my classmates.
Thank you, Jiasheng and Mingyue. Me and my co are mainly working on Arch and Gauge model. First of all, I would like to introduce the volatility clustering. Because of the COVID-19, Australian dollar may fluctuate a lot, especially during the time the virus breaks out. The Australian dollar may have volatility clustering characteristics. However, Arch and Gauge model can solve this problem. By running the Australian dollar dataset plot, we can see the change in variance over the course of the series. We can look at an correlation plot to confirm whether there is an autocorrelation in the variance of dataset or not. From the graph right above, we can see significant correlation in variance up to 20 lags across the blue line, which means autocorrelation 20 days ago has an impact on today's Australian dollar price. Arch epsilon t is a sequence of independent and identically distributed random variables with a mean of 0 and variance of 1. It is usually assumed to obey the standard normal distribution. Sigma squared t is conditional heteroscedasticity. From the structure of the Arch and Gauge model, a large square disturbance which presents part time series will lead to a large conditional heteroscedasticity of the information. However, it tends to take a large absolute value, which means a large disturbance will lead to be followed by another large disturbance. This is similar to the phenomenon of volatility aggregation. Here is the arch result. Omega is the baseline variance for the model. We can think of omega as what the variance would be if information about path variances were not being passed to the model. Hence, the square root of omega would be the standard deviation in returns. This coefficient suggests that the standard deviation of returns should be around what percent per day. Finally, the alpha terms tells us how much the previous period's volatility to add to today's volatility. It turns out that we should not expect too much clamping to be going on. A line plot is created comparing the series of expected variance to the predicted variance. The orange line is predicted variance, while the blue line is expected variance.
Hi everyone, this is Michael. Thanks for the presentation from Cassie. As Cassie said that, since COVID-19, Australian dollar may fluctuate a lot, especially during the time the virus breaks out. The Australian dollar may have volatility clustering characteristic. The Gauge model can also solve this problem. In the next few minutes, I'm going to introduce the Gauge model, and also called generalized autoregressive conditional heteroscedasticity. So what is the Gauge model? The Gauge model is actually an extension of the arch model that incorporates a moving average component together with the autoregressive component, which includes lag variance terms. In the Gauge model, epsilon t is usually assumed to obey the standard normal distribution or the standardized student t distribution. Gauge model believes that volatility of the variable at each time point in the same time series is a linear combination of the squares of the residuals at the latest p time points, and the linear combination of the volatility of the variables at the latest q time points is added. Therefore, Gauge model is suitable for describing the higher order arch process conveniently, when the amount of calculation is not large and has greater applicability. And by now, I searched certain figures from the internet, examining the Australian dollar Gauge volatility and also its analysis. In this graph, it illustrates the Gauge volatility of Australian dollar from November 2018 to November 2019. And in this graph, it shows the same figures which from 2019 to 2020 during the same period. It can be clearly seen that the volatility is bone session in March and April this year. It peaks more than 20%, but in the whole last year, almost all the amounts are under 10%. And here is the parameter estimates for the entire statistic on the website. Parameters have t-value or higher than 2, or the parameters are significant. The high enough beta means the current volatility has high correlation with previous one. It is evidence of volatility clustering. When the virus comes, the volatility of Australian dollar increase. The virus significantly increased the volatility. And at last, this is the arch and Gauge conclusion. There exists the volatility clustering among the Australian dollar. This is the first point. And second point, it clearly shows that COVID-19 may affect the volatility of Australian dollar. And the third part is results are significant among arch model and Gauge model, both. And the last part, Gauge model accounts for the volatility correlation is more suitable for the volatility clustering.